everyone. Thank you for tuning into our session about testing your data science models. Hannah and I will introduce ourselves here in a moment, but we're very excited to speak on this topic today. So like I said, I'm Kelsey Kincaid. I am the Director of Data Science at Evolytics. Evolytics is a digital analytics agency, so we help businesses really make the most of their data.
And I'm Hannah Alexander. I'm our Associate Director of Experimentation and Strategy at Evolytics.
Just a little shameless plug. We at Evolytics love speaking at industry events. We've spoken at a wide variety, including Tableau Conference, AnacondaCon, the Alteryx Conference, and of course, now Experimentation. So we're really excited to be a part of this year. So the real question is not what's different about testing data science or testing a digital experience, because as you can see kind of over here on the side, they're really the same thing. It's just looking at testing through a different lens. And we just really want to focus on why you should be doing this kind of testing. So since Hannah is our experimentation expert here, I'll let her speak to some of the reason why we should do this.
Yes, so I hope everyone here at this conference is as passionate about testing as we are. We would always recommend testing in general with any major change that's taking place with any of your marketing efforts, because in general, this is the best way to eradicate risk. The primary difference with an A/B test versus just rolling out your new machine learning model would be that you are putting yourself at risk of a lot of the common issues that come along with running a pre-post. So when you run a pre-post, you are potentially viewing the results of seasonality, economic impact and political change, client maturity, which comes with time, as well as marketing changes, rather than the actual results being based on the change that's taken place. So, we're not actually able to identify the causality. Secondly, this is kind of specific to machine learning models, but machine learning models are incredibly expensive to run. So we want to make sure that the return on our investment is actually worth the cost of running the machine learning model itself. So running an A/B is actually the best way to measure the potential revenue impact of this new model. And lastly, models occasionally fail in the real world, which Kelsey will now speak to a bit.
Yeah. As much as we as data scientists might not always like to admit it, the models we build are not perfect and can often fail for a variety of reasons when launched in production. One big way that they can fail is something that all of these logos have learned. You'll recognize many of them as some of the biggest names in business and in data. Yet all of these have something else in common, and that's that they have been in the news for having machine learning models that have demonstrated bias. Everything from biased hiring practices, excluding women from technical hiring through the algorithm, to biased healthcare by excluding people of color from prioritized triage, and more. So all of these are horror stories, and it's not because the data scientists sought out to build a model that exhibited these biases. It's because of underlying data and lack of detection. So as data scientists, we should always be testing our models in development and trying to detect bias like this, but an extra layer of protection to keep your business from being on this slide is to go ahead and do that A/B test and use it to kind of back test against bias and make sure that all of our models are being as fair and equitable as possible. Another way that models can fail is when things look really good in development and then don't in production. So I have an example here. We have one model. It's trying to detect the difference between orange X's and blue circles. We've got pretty strong precision, recall, and accuracy with our model being that dotted line in the middle, kind of separating the two. And then we have a second model. This line is a little bit more complicated, but it actually does a perfect job of separating those X's from those circles. And in development, this could look pretty exciting to have a perfect model. But this is also what we tend to call too good to be true. And I'll show you why. So in production, we introduce new data, right, to both of these models, demonstrated by these darker shades of X's and circles. And you can see that things fall within the typical pattern. X's are showing up where X's typically do, circles are showing up where circles typically do. But what you'll notice is actually Model 1 really outperforms Model 2 in production. And that's because this dotted line in the middle might be a little bit simpler, but it really fits the known universe of data. The second model is what we call overfit, and it's where it does a really bad job at doing predictions when faced with new data. So one reason it's important to test is because of overfitting issues like these. You can be really excited about a really strong model in development, roll it out hastily to production, and then realize that you're actually losing money instead of earning money. And we never want to see that happen. And then, like Hannah mentioned, another reason that we always want to test data science models is to quantify that return on investment. So this first example I want to show, kind of proving this, is actually about proving the ROI of a data science program, not just a data science model. This case study comes from a real client, but it's just anonymized a bit. So a client came to us wanting to build out a data science program for their business unit, and they asked us to help them do that. So their goals were to acquire new customers, upsell existing customers, cross-sell to existing customers, and retain customers. Goals that I think most businesses have. So it might not sound very unique, but they really wanted to use data science to drive this. Over the course of 6 months, we helped them build over a dozen models and had some really strong results from A/B testing. So they increased upsell by 325%, decreased churn by 75%, and increased cross-sell by 200%. Those are just some highlights from the results, but what's kind of the message here is they could not prove why data science could make a difference until we ran these A/B tests, and we can put these numbers up here. So if you're trying to justify spend for a team of data scientists or a data science program in general, the best way to do that is to start a data science program and start testing as quickly as possible. Our client was successfully able to justify the spend, and we continue to work with them on their program today. But another way that we can prove ROI with A/B testing is proving the return on investment for each individual model, which Hannah will speak to.
Yes, so this is just an example here. This isn't actually Amazon's real data. But as far as setup, I just wanted to kind of display that, the setup's going to be the same as your typical A/B test. You've got your control, which is either the existing model or your current site experience. And then you've got your test group, which is going to be the new model. One thing that, we always recommend with testing in general is making sure that you can in some way convert your KPI to a primary KPI to a dollar amount, be that, allocating a particular 56 cents per increase in this particular action per user, or, actually using a revenue metric such as conversion and revenue per order. In this case, Amazon has, the new model has recognized that the individual here now owns a dog, and they have increased this new model. This is a singular user example, but new model has increased conversion by 4.6%. We would then use revenue per order to convert this to a overall anticipated revenue increase. And that is where we would want to compare the cost of the model to the anticipated earnings of the new model. So without actually running this test in this fashion, we wouldn't know how the return on investment of this particular model, and if it's actually worth our money to keep this new model.
Very well said. So that's just a really quick rundown of a couple reasons why you should always test your data science models. Just to recap a little bit, one, because we always want to test in this fashion and not doing a pre-post. Two, because models can fail in the real world, either because of bias, overfitting, or any other number of issues. And also because testing is just a really great way to prove the ROI of each model and your program as a whole. Hannah and I both love getting to know more people and also just chatting about these topics. So if you have any questions or just want to discuss, nerd out a little bit, we would love to hear from you. I just put a link to the Evolytics website here, as well as our email addresses. So I hope to hear from you all. I really appreciate your time and hope you all have a wonderful day.